Alright, so we're going to use this set of classifications I have on the upper left over here: synthesis, decomposition, single replacement, double replacement, acid-base double replacement, or combustion. And we're going to classify each of these 15 questions we have on the worksheet here. So the first one we have here is lead chloride. Actually, it's lead 2 chloride. That's really in fact, generally speaking, lead 2 chloride is so much more common than lead 4 chloride. In fact, I don't even think lead 4 chloride even works. When you say lead chloride, that's probably enough. But in this class, you should name this lead 2 chloride because lead does have more than one potential positive oxidation number. This is silver nitrate. Silver only has one common oxidation number, a 1 plus, although there is a rare one, a 2 plus. And this would be lead 2 nitrate and silver chloride. So lead is going over here and joining up with nitrate to make this, and silver is going over here and joining up with chloride to make that. So that's double replacement. Okay, there's no hydrogens in the front, so there's no acid to be acid base. So this is simply double replacement. Okay? Alright, now this one, we have two smaller compounds joining together to make a larger compound. Okay, this is ammonia. You need to know when you see NH3, that's ammonia. Okay, that's just a chemical that you need to know by name. Okay? This would be hydrogen chloride. It's also hydrochloric acid, but if it's not dissolved in water, it's just hydrogen chloride. Okay? But either way, it's fine. You can, at this point in time, you could name this hydrochloric acid. This reacts with that, combining into one thing. Well, the only thing it can be is synthesis. When you combine two smaller things and make a larger thing, that's synthesis. Okay? Here we have a two-part chemical, aluminum chloride, a two-part chemical, sodium and SO4 sulfate, sodium sulfate. The aluminum joins with the sulfate to make aluminum sulfate. The sodium joins with the chlorine to make sodium chloride, and that is again double replacement. Okay? Alright, here we have two small things. In this case, it's an element joining with another element to make a compound. Okay? And that's synthesis. Say what? Zinc. Aluminum sulfate, barium chloride. Aluminum joins with the chlorine to make this. Barium joins with the sulfate to make that. Double replacement. All right, now here we have a larger compound breaking up into separate elements. Okay, this is decomposition. When you break something down, it's called decomposition. Here we have an acid, but there's no base. So this couldn't be called acid-base in the terms that we use in this class. Okay? In higher level chemistry, you'll find out it is actually kind of an acid-base reaction. But what we have is iron, the metal, kicking out the hydrogen. Do you have a pass? Well, you're more than 5 minutes late. You need to go to the attendance office. Iron is kicking out the hydrogen here and joining up with the sulfate inside of this. This is sulfuric acid. If we name it like an ionic compound, it's hydrogen sulfate. This becomes iron 2 sulfate. Iron has more than one potential oxidation number. So because iron is kicking that out and makes the hydrogen by itself here, that is single replacement. You could also call it single displacement. A single replacement or single displacement would be a correct answer. Okay? Alright, here we have, I probably should have changed that, but that, huh? Single replacement or single displacement, either one of those is a correct answer. When I first gave you the list of names and stuff yesterday, I mentioned displacement is an acceptable answer here as well. Single displacement or single replacement, either one is correct. Okay? Alright. This is oxygen reacting with what looks to be mostly like a hydrocarbon. You are producing carbon dioxide and water. Okay, this would be combustion. I know I haven't taught you guys that you can have oxygen in a hydrocarbon, all right, but the hydrogen and carbon compound should make it pretty clear. Did anybody get that wrong because this confused them? No? Okay, then we'll count this as one you can get credit for, a combustion reaction. All right, now here we've got a compound that has a hydroxide on the back. Here's a compound with hydrogen on the front, so this must be an acid. It's sulfuric acid. This is magnesium hydroxide. The magnesium is going to join up with the sulfate to make this. The hydrogen on the front of this acid is going to join up with the hydroxide here to make water. That is acid-base. Okay? It's acid-base double replacement is the way I ask you to classify it. Acid-base double replacement. Okay, that's the way I want you to classify it. All right? Here we have a hydroxide, but there's no acid here. So it's not acid-base unless you have both an acid and a base. Okay? So the sodium does join up with the sulfate, sodium sulfate. Copper does join up with the hydroxide, making, well, this is copper 2 sulfate, copper 2 hydroxide. So that's double replacement, but it's not acid-base, just simply double replacement. All right. This is clearly a hydrocarbon. Oxygen. If you react to hydrocarbon and oxygen in this class, the assumption is that's going to be combustion. Now, the plus is you have water and carbon dioxide over here, further clarifying that it's combustion. Okay. Did you write your name on the top of that? I need your. They don't usually write your name on it, so I need your name written on the top of that thing there in pen, please. Okay. All right, here we have two smaller, well, we actually have two elements here. Two elements joined together to make a compound. That would be synthesis. All right, here we have a two-part compound, magnesium phosphate, and hydrogen's by itself. Hydrogen is going to kick out the magnesium and join up with the phosphate to make phosphoric acid. Leaving magnesium, this part right here is get kicked out to be by itself. This is single replacement. Single displacement is also an acceptable answer. So here we have a compound that is breaking up into two smaller compounds. So that would be decomposition. We've got an element by itself. Here's a compound. The element is going to go over here and kick out the element that's light. Chlorine is one of the halogens. Bromine is also one of the halogens. So because it is going to replace that, so that potassium is now joined up with the chlorine here, leaving bromine by itself, this is single replacement or single displacement. Okay? So there are 15 problems here, so we're going to have this will be a total of 15 points for this homework, okay? 15 points.